So looking at that data, it didn't bear out what they were saying at all. And yeah, if they went out and bought these additional packaging machines, they'd have really just ended up with more packaging machines sitting there idle because the problem was somewhere else.
Growing a business requires a holistic approach that extends beyond sales and marketing. This approach needs alignment among people, processes, and technologies. So if you're a business owner, operations, or finance leader looking to learn growth strategies from your peers and competitors, you're tuned into the right podcast. Welcome to the WBS Podcast, where scalable growth using business systems is our #1 priority. Now, here is your host, Sam Gupta.
Hey everyone, welcome back to another episode of the WBS Podcast. I'm Sam Gupta, your host and principal consultant at digital transformation consulting firm Elevate IQ. If your teams report problems in the production line and the capacity, their answer is often additional machines or people. Solving each problem with an additional body or machine results in unused capacity and unnecessary spending when the problem could be somewhere else. While there are tons of data available from machines and processes to make prudent financial decisions, interpreting data requires experimentation, design, and understanding each variable that may cause deviations. In today's episode, we have our guest, Martin Davis, who discusses the strategies to improve your manufacturing facility's capacity and increase the overall equipment effectiveness of your equipment. He also discusses several stories where he used data to pinpoint the actual bottlenecks in the process, which saved millions of dollars in savings in unnecessary additional equipment purchases of equipment. Finally, he discusses several issues around data quality, describes the difference between operational and business technologies, and how each of these components fits in the enterprise architecture. Let me introduce Martin to you. Martin Davis is a CIO and executive with many years of IT experience, most in manufacturing, including automotive, tissue, diaper, and fries. He has been heavily involved in the operational technology side about 10 years ago, using data to drive manufacturing improvements. Through these engagements, he has been able to save millions of dollars by getting the correct information to the right people to make the right decisions. With that, let's get to the conversation. Hey Martin, welcome to the show.
Hey Sam, it's really good to be here.
And I am super excited to talk to you as well. Just to kick things off, do you want to start with your personal story and your current focus, Martin?
I'd be pleased to, Sam. So I'm a long-term IT person, CIO for a number of different companies. But a few years back, I got into the manufacturing space more and started to understand how do we use information to drive manufacturing, and that whole how do we get the effectiveness of our equipment up? How do we use data? And the company I was working at the time, I discovered that they really were kind of using bits and pieces of data here and there, and there was no coordinating effort, and they were not making the most use of their data. And I really got into that in there. And over a period of a number of years working with the plants and working with the technology people in the plants and things like that, really got into the use of data to drive productivity, drive improvements, get a lot more value from machines and the things they already had. So that was kind of how I got into it. So I kind of started on the IT side and then kind of added on to it the more operational technology side of things. And I did that over a number of different companies and in a number of different industries.
Okay, this is going to be so amazing, and whenever I host anybody who has the data background, they are probably going to have the most compelling stories, and I am looking to dig deeper into those. But before I do that, we have one of the standard questions for every single guest, and that is going to be your perspective on business growth, Martin.
So if I think about business growth, I think about different aspects of that. So you can think about it from a perspective of where do we get more sales? How do we drive more volume to our manufacturing, our plants, whatever else? I think of growth from how do we make more use of the equipment we've got? Can we run extra shifts? Can we run the machines longer? Can we produce better quality? all of those different aspects, which starts to tie into our discussion over equipment effectiveness. And if you can both sell more and produce more with the equipment you've got, then you're adding more to the bottom line. And from a kind of a CFO's perspective, that's kind of music to their ears. It's how do we actually get more from what we already have? And I think that's my kind of quick perspective on growth. And I look at it from a perspective of how do I help the business move forward? How do the business get more from the equipment? How do they produce better quality? How do they make more use of what we already have without massive new investments? Some of those aspects. But then you can also take that to the next level, saying if we're really successful at doing that, then we can go after more and bigger business. We can add and increase our footprint. We can add more machines. We can add more people, and we can grow further.
Yeah, great perspective. And I am all in for improving the existing infrastructure. Whatever we can get out of the existing investment, I think that's smart. Okay, so Martin, obviously you have spent a lot of time overall in the industry, in the manufacturing, in the IT space, and I can almost guarantee that you are going to have very compelling stories. So I want to dig into some of those stories. And one of the things that I caught as part of your description and also your perspective on growth is overall data driving the performance. And when you drive the performance of the existing investment, existing machine, so do you have any stories that you might be able to share around data really driving the performance, and you were involved in that performance initiative? You could bring really high performance that was not possible unless you digged into this data, you understood the insight from these fragmented pieces, and you brought to the attention of, let's say, the finance people or the procurement people, and you were able to fix that, and finally you were able to drive the performance. Do you have any stories around that by any chance?
Yeah, so one kind of story that springs immediately to mind was we were looking to try and get some improved capacity from one of the plants and try and produce more with what we already had. And the plant manager's immediate reaction was, we have bottlenecks on the packaging side of things. We buy some more packaging machinery, then we can produce more from the plant, because that's what's holding things up. And they got estimates of buying the brand new Bosch packaging machines, quite a big investment there, and they could have spec'd all of that out. They worked out the layout, where they'd go, how they'd rearrange that part of the factory to fit the new packaging machines in, and dug into it. They were about to pull the trigger on buying these additional packaging machines. And I kind of started getting involved at this point, and I said, well, have you pulled the data to actually look at what's going on? Because so far this was all around people's kind of gut instinct and hunches, and said, well, we know we have a bottleneck in that area, and therefore this will fix it. So, and I kept on them, have you actually pulled the data? And they started pulling the data, and we kind of gathered the data from the existing packaging machines. And when we started looking at it, we found none of the existing packaging machines were more than 50% utilized. So looking at that data, it didn't bear out what they were saying at all. And if they went out and bought these additional packaging machines, they'd have really just ended up with more packaging machines sitting there idle, because the problem was somewhere else. So we started actually digging in further and encouraged the production engineers to look at the data further up the line and start looking for where there might be bottlenecks. And what they discovered was there was a bottleneck slightly earlier in the process, which was delaying finished goods actually coming to packaging. And by digging into that, then they could look at what the causes of that bottleneck was, what additional changes they can make to the line, the way it was flowing, additional machinery, and an earlier piece of the line. And therefore, that would remove that bottleneck, allow product to flow more quickly to the packaging machines, and actually no additional packaging machines were needed, because you got like 50% capacity was sitting there already.
Okay, so very interesting story there. And as you know, Martin, I'm more of the detail guy, so I am going to dig deeper into the story. So number one thing, obviously, I need to understand the product line a bit better to be able to understand why there was a bottleneck in case of packaging. This is a very common situation in most manufacturing. I come across this all the time, where customers are going for additional facility, additional machine, additional process, and the majority of the time, the problem is going to be somewhere else, and they might be simply adding the resources in their manufacturing process, but they are not going to be able to get the result. So in this particular case, when they found out that the problem was really in packaging, what was the thought process behind that? Do you know the background of the story by any chance? What kind of products they were building? What were the key symptoms that they found out that, finally, okay, packaging is the problem. Okay, I'm actually honing in myself in the packaging. So do you have any more background there in the story by any chance?
Yeah, well, this was to do with food production, and it was a process manufacturing situation. And I think the reason they jumped to the conclusion that the problem was in the packaging side, because historically they'd had problems there. That I think some of this was history, some of this was, well, we always have problem in the packaging, therefore if we buy more packaging machines, that's going to sort that problem out. So it was kind of history and the kind of people been doing this for a long time. So they jumped to conclusions, and they started assuming that was where the problem was, because that's where they'd already had problems in the past, without actually getting facts and data to prove or disprove that. And I think that's kind of a cultural issue you find in some of these, especially with engineers that have been working in a certain plant for many years, that they know these plants inside out, and they have gut feels to what the causes are, and they jump to conclusions. And they've got some really good instincts. You've got some really good engineers that have been doing these parts. But now you're getting a kind of almost another wave of younger engineers coming through that are more likely to use data. So you're starting to see kind of things change related to this. And in this situation, it was very much a case of history and jumping to conclusions and not checking it out. And that led to them going down effectively a dead end, which they'd have spent quite a lot of money for no gain at the end of the day.
Yeah, so again, interesting story there, and I have seen similar situations, especially in the manufacturing environment. If the packaging is going to be troublemaker, let's just call it troublemaker every time. So good insight there. So now let's go back to our data conversation, and you did mention that the utilization of these packaging machine was only 50%. But even in case of data, when we look at data in the organization, unless somebody is really digging deeper into the quality of the data, whether the data set is really accurate or not, sometimes even the data could be sort of the cultural play, because you might say that, it is 50%, you might have fancy deck, you might be presenting to the executives, and nobody really cared to look at the underlying data, whether the utilization of that machine was really 50% or not. So can you go back to that story and talk to us about how did you find out that the utilization of the machine was 50%? Now, I don't know if they had, let's say, the corporate ERP system that was producing the data. I don't know if these machines were actually connected with the ERP system or MES system. So maybe you want to talk about the architecture a little bit and then describe how you found out that the utilization of the machine was 50%.
Okay, so when you talk about data in a manufacturing plant, it's sometimes often referred to as time series data, which is a very very specialized type of data. Thousands of tiny bits of information coming off of a sensor on a machine every second. And that needs special type of handling. So we often use something called a data historian, industrial data historian. One of the biggest on the market is OSI Soft Pi, used by a lot of big manufacturers, etc. And this has a specialist capability of being able to process and analyze and store thousands and thousands of tiny bits of information a second. So one of the reasons I got into driving this use of data to drive manufacturing was that they had some of these tools in place but weren't really making proper use of them. So we had bits and pieces of data coming from different bits of the production line, but there was no consistency. There was holes, there was pieces where we weren't getting data. So part of what I was driving was a strategy where we've got more consistent. We identified key machine centers on the production line to get data from. And then the process engineers could then use that data to analyze what was going on the production line. Maintenance could use it to look at the behavior of the machines when they've got a problem and other aspects of this. So in this case here, we knew we already had data from some aspects of the production line. We knew we were missing data from the packaging side of things. So the first step was to actually make sure we were connecting and pulling data from those packaging machines and pulling it into this data historian, this specialist type of database, so it could be analyzed. So some of the first steps was actually getting the data, and then the analyzing of the data and getting the engineers to look at the data to understand what was going on. And then looking further upstream into other machine centers to identify where things were flowing, where there was things being held up. So it was around this overall strategy about getting data and using data to make decisions. And that's the fundamentals of what, people talk a lot about Industry 4.0. And fundamentally, Industry 4.0, when you peel back all the layers of robotics and other tools and everything else, fundamentally, it's about using data to make decisions. And so this, in the rawest form, was getting data from different bits of the production line, understanding what the problems were and where the problems were, and using it to make decisions. And the first decision was don't go buy any more packaging machines because you don't need them. And then the second decision was, okay, where have we got a bottleneck that's causing us a problem? And if we invest in removing that bottleneck, then we're into a situation where we can actually get a free flow of production going on and flowing to the production line, and our overall capacity of that plant or that production line has increased considerably just by removing bottlenecks. There's very little extra investment needed, but we're removing a problem and getting the bottom line. We're getting more product coming out, which we can sell, and that's going to put more money on the bottom line for the CFO.
Okay, amazing insight there. So in this particular case, obviously you had access to a lot of different data from the sensors, and I don't know if these machines were really modernized in providing the kind of data that you were looking for. I am still looking for the clue of that 50% utilization, because we want to make sure that the utilization was really 50% and it was not really the misinterpretation of the data. So let's take a scenario here. Okay, so let's say if I'm the manufacturing executive, I have the similar plant here. Okay, my team keep complaining that, you know what, I have problems in the packaging line and I need new machine. Okay, so let's see if I want to replicate the same process here in terms of analyzing this data on my packaging line, and I want to measure the overall equipment effectiveness of my equipment. So what is going to be my process? Do I need to hire more people? Do I need to buy a new software to be able to analyze this? What do I need to do to find my metric? So number one, that I am able to spot that the problem that I am going to have in my plant is going to be in the packaging line or whichever equipment that I may have. And then it's not because of something else. So what is going to be my process, Martin? Let's say if I have the same problem as you had in your story.
Well, I think it really depends on your level of maturity to start with. If you don't have data that you can grab from that machine already, then my first step would get someone with a stopwatch and a clipboard to actually monitor the machines and see how much of the time they're active and how much of the time they're sitting idle. So start simple. Start really simple with a stopwatch and a clipboard, or a phone with a stopwatch on it, whatever. But by doing that, you get some basic data about what's going on, and you can see those machines are not working all the time; they're sitting idle a lot of the time. So what's going on? So that would be my first step. If you have machines that are capable of providing you with data, and my next step would be, okay, can you talk to the manufacturer of those machines? Do they have software that comes with them, or that they can provide you with, that easily pulls that data from the machines without much investment or anything else needed? That would be my kind of second step. And my third step, if you're able to be even more sophisticated, would be to work with a system integrator, and there's some good system integrators around who can then connect your machines through to an industrial data historian like Pi or whatever else to pull it into a centralized database. So depending on what level of sophistication you're at, one of those three routes will get you some more information. And even if it is only just somebody with a clipboard and a stopwatch, that will give you the basics to understand what's going on. And obviously the higher up the kind of maturity level you are, the more sophisticated you can be in your analysis.
Okay, amazing. So I am actually going to add some more color to the story. So let's say I spoke to my manufacturer. I know that the machine is actually capturing some data last time and they sold it to me. it was fairly expensive. So my assumption is going to be that it is probably collecting some sort of data. Okay. And I spoke to my manufacturer and they did say that there is some sort of data available. So now they are going to give me some sort of file, right? So what am I looking at in that file? Is it going to be some sort of CSV file? Is it going to be XML file? Is it going to be a data dump? What kind of elements am I looking at in the data? Can you provide some more color into that? What kind of skill set do I need to hire? Let's say if I want them to analyze that data, because my machine manufacturer may not help me to analyze this data. So what do I need to look for when I am looking at this data? How can I drive the conclusion that my overall equipment effectiveness is going to be 50% or 70% or 60%?
Well, I think the first thing you're going to get is going to be some data around at different points in time what the machine was doing. So, for example, it was active or inactive. So at the very basic level. And from that, you can start to actually, you can pull that into Excel or pull that into some other tool. But it's going to give you effectively a timeline by which you can see how often the machine's sitting idle and things like that. And any engineer, a process engineer, is going to be very familiar with that type of information. So most manufacturers are going to have somebody who's got some process engineering background on staff. Or they can go out and go to a suitable company to get some help.
I think it's crystal clear for me in terms of understanding whether the machine is active versus inactive. It's a binary flag that I'm actually trying to analyze. Okay, the sensor is really reading that, this time the machine was active, this time the machine was not active. Now, in your experience, is that the reliable indicator to analyze whether the equipment was effective or not? Even if the machine is going to be active, does that mean that it's being utilized completely? Is it like on and off switch in the machine, and based on which we are deciding that, this is going to be really effective? Or are there any more data elements that come along with just the active and inactive flag from the machine data?
Well, I think you have to look at, first of all, what is the expected performance of that piece of equipment, whatever it is. And obviously the manufacturer can provide you some guidelines on that. We expect it to be able, if we stay with the example of the packaging machine, we expect it to be able to pack 20 bags a minute or whatever it might be. Whatever that number is. And so if you then have that amount and you can say how many bags are we actually producing in an average week versus what we would expect it to be, that will give you a performance rate, which is one of the first components of OEE. So if you've got that performance rate, you can say, okay, manufacturer expects it to be performing at X, we're performing at Y, so we're only at performing 80% of the capacity we should be. So our performance rate is that. So that's kind of the first piece of information. Are we performing at the rate the manufacturer expects us to be? And you can then start to dig into, well, why is that? Is that because of, as we talked about here, bottlenecks or speed of the production? So you've got to actually work out for your situation what is the expected rate you would normally get, and then what are we actually getting this week, last week, the week before, and that gives you a kind of a perspective of your performance over time versus what you think your maximum capacity is.
Okay, amazing insight there. And, I am going to ask you one more question related to this specific story, and that is going to be, let's say, if I look at some of the newer machines, right, they are providing this out of the box, especially the metric, the overall equipment effectiveness. And I don't know how reliable that metric could be because they are building that as part of the machine. I like to compare this with my car. When I buy my car or drive my car, then I have this check engine indicator on all the time. Just because I may not be following the guidelines of the manufacturer, I may not be utilizing my car the way it should be utilized. Now, in case of machine as well, if I completely listen to whatever manufacturer is saying, sometimes that could be very expensive. And I don't know how many manufacturers really follow the guidelines of the manufacturer, because then I probably need to hire one more person who is going to be expert at that machine and maintaining those machines. So I don't know if in your experience you have seen that these machines are exactly maintained the way manufacturers want their customers to maintain. And if the OEE indicator that we are going to get, let's say right from the machine, if that is going to be reliable enough to be able to measure our effectiveness of the process. So in your experience, that out of the box OEE that we get from either the machine or the ERP, is that reliable enough to be able to trust and create processes around that?
That's a difficult question to answer. And I think you have to look at it. What is OEE? OEE is effectively a meaningless number. Put in perspective, it's really a meaningless number. But what it does give you is allow you to compare the performance of similar setups versus each other. So if you've got two production lines with similar equipment or the same equipment in, then you can use OEE to compare the performance of those two different lines, or machine centers within those lines, or whatever it might be. So you can't really rely on what a manufacturer is going to tell you, I think, is the bottom line of the story. And you're better being able to calculate OEE outside of what a machine is telling you, because that allows you to calculate OEE for a complete production line, a complete facility, a manufacturing plant, or whatever else. So ideally, you want to be able to calculate OEE at different points for different places and compare them. If you've got the same packaging machine on two different production lines with similar kind of setups, why is one have got an OEE of 75 and one's got an OEE of 60? And you can then start looking at what's different and is it to do with the products being produced and the lower effectiveness because you've got to run the line slower because of the type of product being run, even though the machinery is the same. And you have to start looking at those different aspects. So OEE it gives you a number that you can compare with and compare that line against history of that line. So you can look at it over time. Are we improving OEE? Is the OEE reducing? And then you have to look at the different components of OEE. So we talked about performance quite a bit. The other two components is quality and availability. So you need to look at those as well. And each of those has different things that can actually impact it. Quality rate is how much good product you produce versus how much scrap. And what's the reason you might have scrap? What's the reason things may be coming out that are not up to scratch? And then the last one's availability. What's the availability of this machine? And availability translates into downtime. You've got obviously planned downtime, such as how many hours you're planning to run, what breaks, what maintenance you're doing, what cleaning or changeovers required between products or between shifts. And then you've got the unplanned downtime side of things. So, what are the reasons for unplanned downtime? Is it a problem on one of the machines? Is it a problem getting raw materials that's forced you to stop? Or one of these other aspects? And by looking at those different perspectives on what's causing your downtime. So for example, a lot of companies have found that their planned downtime has increased considerably with COVID because they're wanting to keep the physical shifts separate. They're wanting to do cleaning of workstations and that between shifts to avoid COVID cross-contamination. And so changeovers and cleaning, it's increased the amount of planned downtime they've had to actually embed into their calculation OEE. So that circumstances are changing, so your OEE over time has gone down. But then you look at the unplanned side of downtime. So what are the causes? So mechanical breakdowns. So why are we getting more mechanical breakdowns? Is it one particular machine? Is it spread across a number of different machines? What are maintenance looking at as to the root causes? Is it one machine that's breaking down quite often? And can you dig into that and find out, and do you need to replace that machine? Do you need to service it? Do you need to get the manufacturer to help you? What's the causes of those downtime? If your downtime is a number of different things, is it because your production line's getting old? You've got to look at some form of renewal. Do you need to maybe run the production line at a slower speed because the older equipment can't cope with the higher speed you're running? And so these different aspects that you need to dig into. And a lot of this comes down to getting data on what's going on. So, for example, when we talk about measuring downtime, putting a sensor on a machine to find out if it's going or not. And we did some digging using IoT sensors on a machine to tell us whether, on an older machine we couldn't connect to find out is the machine on or off. Just very simple type stuff. And what you start finding out very quickly is what you thought the amount of downtime was versus what the actual downtime is are totally different, because there's often small bits of downtime and that the person monitoring the machine might not notice, or, for example, the time the machine takes to restart once it's stopped. That ramp-up time is effectively a form of downtime, because instead of running at 20 parts per minute, you're running at 10 parts per minute, 15 parts per minute, or whatever as you ramp up, is another form of downtime. So it's lost production. So all of these aspects, and grabbing this bit of data, you start to understand the fuller picture. And it's funny that people are usually surprised at the results when they really get a system telling them the actual amounts of downtime they've got. And if you define downtime as any periods of time that the machine is not running at its normal run speed, you'd be surprised at how much downtime you really have. And that downtime translates into lost productivity, which translates into finished goods you're not producing, which translates into money you're not getting on your bottom line.
Yeah, so this is great. Overall, based on what you described, the insight that I gather is obviously there are a lot of different inputs there, and the output is obviously going to be to find the problem areas that we might have in our production process. And when we have too many inputs, sometimes they could be very misleading. So we need to have some sort of systematic process to be able to understand which is the input that is actually causing the problem. And I go back to my background in sort of the experiment design. So in case of this, let's say if you are trying to analyze these so many different inputs, I mean, the inputs could be because of the equipment, it could be because of the process, it could be because of quality issues, it could be because of the availability and downtime. So if I want to compare two different processes and see if the OEE that I'm getting from the machine is reliable enough or not, and if I'm pinpointing the right problem, then I should be able to design some experiments, and I probably need to run these experiments on a continuous basis so that I can glean into insight, okay, where the problems are. And I can almost guarantee that this is probably going to be a continuous process overall in the manufacturing environment, where you are always going to find some sort of improvement areas. So Martin, let's say if I come to you as an executive, as a manufacturing executive, that I know that in deep down in my heart that I got tons and tons of problems in my manufacturing facility, and I can get so much out of my existing equipments, existing people, existing processes. So what will be your recommendation or the process to design these experiments so that we can analyze the OEE over the period of time? That is number one, and then compare different variables that may be driving the behavior of OEE so that we can clearly pinpoint where the problems are.
Well, I think I'd start by saying, what data do we have? What data have we been gathering? What data do we need? So what are the key machine centers within each production line? Do we have basic data about each of those machine centers, about what's going on? And then if we don't, how do we fill those gaps? So we've got a consistent set of data. And how do we, as you said, the design of experiments, how do we prove that each of those data points is accurate? It's very simple for an electrician in a plant to make a change and disconnect a number of sensors. So how do you make sure that the data points you're getting are valid and continue to be valid? Are they within limits we would expect, or are they all of a sudden trending to very high amounts or very low amounts, or zero? All of those types of aspects. So have we got the data we need? Is the data valid? And as you said, ongoing checking or having routines that check and make sure that data is coming in and is within reasonable limits. That would be my first port of call is identifying that. In the parallel to actually identifying what data we need and whatever else, it would be a discussion with senior management over what are your objectives? What is your actual business strategy, and how does that translate into your manufacturing side? Is your strategy to max out your production machinery? You want it to run as fast as possible, or is it the highest quality? In which case, you want to run slower, but make sure that we're hitting all of our quality marks very well, etc., etc. So the business strategy and where you're driving is very important to how you utilize that data and how you move it forward. And then obviously, as you said, once you've got that kind of picture painted and you've got the data, you're then looking at, okay, how do we optimize different aspects? Are we optimizing quality? Are we optimizing performance? Are we minimizing downtime, or some combination of those things? And it's got to be the people involved. It's got to be the engineers in the plant involved. This is not something someone comes in and does to them. They've got to be involved all the way through this. And this is their plant, and they all feel very much ownership of their plants. Is, okay, how do you help them to structure their approach so that they're optimizing the right things and they're driving the bottom line for the company, for the CFO, for the CEO?
Okay, so one more question related to overall in terms of arranging this infrastructure, and I don't really know how much effort is going to be involved in doing the experimentation design as well as in the data collection. So the data collection that you are talking about, let's say if I am, 30, 40, $50 million company, maybe $100 million company, I have got 2 or 3 different facilities, maybe, or maybe just one. Okay, and I am trying to gather this data, okay, and I want to make sure that I have deep understanding of my processes. So what am I looking at in terms of getting this data somewhere so that this is in a understandable format? So am I looking to create some sort of data warehouse here? Am I looking for some sort of visualizer tool, or is this going to be manageable, let's say, in the spreadsheet? What kind of tools do I need, and what kind of effort is going to be involved, number one, in the data gathering, and number two, in analyzing the data?
Well, I think for a company, a small to medium-sized company, you're going to quickly outgrow trying to do it in a spreadsheet.
Okay.
And if you've got getting thousands of pieces of data per second, whatever, you need some form of specialist tool to store it and analyze it. And an industrial data historian is the best tool designed for that purpose. And they vary from relatively low cost off the shelf ones through to more higher end ones like OSI Pi. So I would be looking at and maybe talk, if you've got a system integrator you've used in the past, talk with your system integrator about tools they're familiar with. Because they will help you about being able to integrate and get this data and get access to this data. And most engineers will have familiarity with time series data as well. They'll be used to using some of this information to make the right decision. So having that strategy and then structure about getting your data, getting some of the right tools like that. And I think in the future we're going to see more. To put kind of a catchphrase of data lakes. Which is kind of one of these buzzwords that goes around. I think we're seeing more machine learning and artificial intelligence being able to take this dump of data coming from manufacturing and identify patterns within it. We're seeing the growth of that type of approach. I don't think it's mature yet. The more traditional way of using a data historian is probably more reliable. But I think in the future, we're going to see more of that type of things where a more generalized way of storing these tons and tons of data coming from production line and analyzing it will take place.
Okay, so one more question I'm going to have related to overall in terms of the alignment of this data historian tool that you mentioned with respect to the enterprise architecture, right? So let's say if we look at the overall enterprise architecture, that if we look at the manufacturing shop floor, there's going to be some sort of MES system. There's going to be some sort of ERP system, obviously. ERP system may not be connecting, let's say, as much on the shop floor. It is probably going to be MES system. They might have some sort of SPC tool that they might be utilizing. So where is this tool, the tool that you are recommending? Is this part of the MES? Is this built as part of the MES? Is this a separate tool? How does it collaborate, let's say, with MES? Because MES belongs to the shop floor as well. So where does this tool belong to in the overall enterprise architecture?
Okay, so I think you have to draw a line between the business technology and the operational technology. Okay. And on the business technology side, you've got your ERP, which then feeds down into your MES, your manufacturing execution system, which is telling you what to make. You get into your production scheduling, it gets into what raw materials are required and what finished goods are being produced, etc. So that's your MES. On the operational technology side of things, you've got what is actually going on the manufacturing line. And that data feeding into a data historian. If you're using a tool like SPC, Statistical Process Control, SPC will sit on top of a data historian. It will sit on top of the sensors on the machines. So that's more on the operational technology side of things. You may get summarized results from SPC or from data historian that you're then feeding into your MES or something like that. But there's a pretty strong barrier between the two. One's really around what's happening second by second with your manufacturing. The other is really around what you need to be producing, what you have produced, the raw materials and things like that. So that there is a separation there and segregation between the two. So I think if that's kind of, you look at your architecture, yes, you need MES and ERP data to give context to what is going on in the manufacturing. And you will use that in conjunction with your data historian and with SPC. Because, for example, if you're looking at an SPC chart, you need to know what product you're producing to know where your upper and lower control limits are for your SPC. And those upper and lower control limits will be dictated by the SKU, the product you're producing, or whatever else. So that contextual information coming from the ERP and the MES is required in the manufacturing side of things. But there is a kind of a barrier disconnect between the two. And I think what we're seeing is that barrier is becoming more broken down as time continues. And there is more need from information flowing. But they are pretty segregated in lots of ways.
Okay, Martin, that's it for today. Do you have any last-minute closing thoughts by any chance?
I think my biggest thing, and I say, I'm a CIO, a lot of IT experience, got more into the manufacturing side of things. And the way I look at this is, it's, as you said, it's a data problem. Is get data, start small, look at where you have a problem, look at getting data related to that problem and build on that. But beyond everything else, even though you start small, have a clear vision on where you're going. What are your goals and objectives from doing this? What is your strategy? And then lastly, get the staff involved. You need the people to be involved throughout on this, because without their knowledge and expertise, you're going to flounder.
Okay, and my personal takeaway from this conversation, Martin, is going to be that sometimes the data may provide you misleading results just because you may not have put enough effort and investment in that. But data is where the real insight exists and real opportunities exist in improvising your existing environment, in getting the most ROI from your existing investments. On that note, Martin, I would like to thank you for your time. This has been a very insightful conversation.
Thank you, Sam. I really appreciate it.
I cannot thank our guests enough for coming on the show, for sharing their knowledge and journey. I always pick up learnings from our guests, and hopefully you learned something new today. If you want to learn more about Martin, head over to industry40iiot.com. It's industry40iiot.com. Links and more information will also be available in the show notes. If anything in this podcast resonated with you and your business, you might want to check the related episodes, including the interview with Mike Yost, who discusses the differences between performance management, production management, and asset management on the shop floor. Also, the interview with Martin Cloak, who discusses different barriers associated with artificial intelligence and Industry 4.0 adoption. Also, don't forget to subscribe and spread the word among folks with similar backgrounds. If you have any questions or comments about the show, please review and rate us on your favorite podcasting platform or DM me on any social channels. I will try my best to respond personally and make sure you get help. Thank you, and I hope to catch you on the next episode of the WBS Podcast.
Thank you for listening to another episode of the WBS Podcast. Be sure to subscribe on your favorite podcasting platform so you never miss an episode. For more information on growth strategies for SMBs using ERP and digital transformation, check out our community at WBS.rocks. We'll see you next time.